Okay, I made a mistake here, just a small one. I copied this number down wrong. Should be a -2 right there. Okay, that makes sense of the rest of the example. Okay, so what was the issue here? Why is this not always consistent? Well, it's because this, oop, no, let's say, well, it's because the matrix A does not have a pivot for every row. That turns out to be the issue. So this is described in Theorem 4. Okay, Theorem 4 says the following are equivalent. The following are equivalent. So I'm going to have four statements for matrix A that is M by N. So I'll have you recall this is the number of rows and N is the number of columns. So four statements. The first statement is what we were just talking about. AX equals B is consistent for all B in R M. 2. Every B in Rm is a linear combination of the columns of A. 3. The span of the columns span A1, A2, AN is equal to all of Rn. And finally, 4, A has a pivot for every row. Okay, pause the video and write all that down. I'll say a few things about what's written here. Okay, how do I know this is M? How do I know that's M? M is the number of rows here. Okay, so M is how many entries are in that vector B? Well, look here. That's my vector B. And you can see that the number of entries in B has to be the same as the number of rows in the matrix A. Okay, so that tells me this must be the M and not the N. What else do I want to say? Oh, I want to underline that these are the columns of A. And I want to just talk about number 4 one more time. Okay. Look at the example we just did. If we look at the matrix A, which is this guy here, we can see that it does not have a pivot for every row. It has a pivot for the first row, but not the second. Okay, so that, I hope you see that that is what kind of screws things up here. Okay, but it turns out that if A, does have a pivot for every row, then automatically um, this AX equals B is consistent. For any B, you could choose in R M